Tunisia, North Africa, March 1943. A weary American infantryman crouches in shallow desert sand, his hands gripping a folding shovel. Enemy artillery screams overhead, and he needs a foxhole. Now he flips the blade perpendicular to the handle, locks it at 90 degrees, and slams it down hard into the rocky ground. The locking nut gives. The blade folds. He tries again. Same result. Around him, captured German shovels bite deep into the same unforgiving earth, held solid by soldiers who learned months ago which tool many trusted more in the field. The American M1943 entrenching tool looks almost identical to the German Klappbatten. Same folding design, same compact size, same multi-position blade. But there are critical differences. Something invisible until the moment you need it most. And those differences are frustrating American soldiers who struggle to dig fast enough when the shells start falling. This is the story of how the United States copied one of Germany's most brilliant field innovations, kept nearly every visible feature, changed key hidden details, and created a tool that looked perfect, but too often failed when it mattered most. By early 1943, American forces in North Africa face a brutal reality. Modern mechanized warfare demands speed, mobility, and the ability to dig in fast. The M1910T, handle entrenching tool carried by U.S. troops since World War I, is a relic. 22 in long, 7 in wide, non-folding, heavy. It takes up massive space on a solder's pack. The wooden handle used on most versions snaps under stress. The blade bends, and worst of all, it's slow to deploy when enemy fire erupts, and every second counts. A quartermaster observer in Tunisia documents the crisis with stark clarity. He writes that the entrenching tool is one of the few items the fighting soldier will not discard, but will actually carry right into battle with him. It is probably the most useful utensil in his possession. In every new position, either advancing or retreating, it is absolutely necessary that a foxhole be dug. When foxholes are needed, they are usually needed in a hurry and deep. The M1910 cannot deliver that speed. It cannot deliver that depth, and soldiers are suffering for it. Across the North African desert, American troops watch German prisoners file past, carrying compact, folding shovels on their belts. These German Klappbatten fold into 18.5 in. They lock solid in multiple positions. They're fast to deploy. They're reliable under stress. And American soldiers immediately recognize what German engineers perfected years earlier. This is the shovel every infantryman needs. The German Klappbatten appears in 1938, the first military folding shovel ever adopted for mass use by a major army. German engineer specifications call for a blued stamped steel blade, hinged to a folding tube, riveted to a hardwood handle. The revolutionary feature is the locking mechanism, a deep red-ribbed bakelite collar that screws down tight around the handle shaft. 3 positions are available, fully extended at 180 degrees for standard digging, perpendicular at 90 degrees for hacking through roots and frozen ground, and folded shut at 0 degrees for compact carry. The bakelite locking collar is the genius of the design. Bakelite is an early thermosetting plastic hard as steel, when cured resistant to temperature extremes, and crucially, it provides massive grip area with deep, ribbed grooves. A soldier can hand-tighten this collar to hold the blade rigid, even under heavy leverage. The tempered steel blade itself is robust, designed to take abuse. The hardwood handle is secured with steel pins. Every component is built for demanding field conditions. German troops prove the Klappbatten's worth across Poland, France, and Russia. It digs trenches in frozen Stalingrad dirt. It chops roots in French forests. It survives drops from trucks, impacts against rocks, and temperature swings from -40 degrees F to 120 degrees in the shade. The tool becomes legendary, and when American forces capture German supply dumps in North Africa, they immediately start hoarding these folding shovels. Supply officers notice their popularity. Within months, the German Klappbatten becomes one of the most prized pieces of captured enemy equipment. In late 1942 and early 1943, the U.S. Quartermaster Corps recognizes reality. American soldiers need a folding and trenching tool. The captured German examples provide a perfect blueprint. Army engineers at development facilities measure every dimension of the Klappbatten. They photograph every feature. They analyze the blade curvature, the hinge mechanism, the handle length. They test the folding positions. And then they begin manufacturing the American version, the M1943 entrenching tool. The M1943 copies the basic concept closely. It features a folding blade affixed to a hilt riveted to a one-piece wooden handle roughly 16 in long. The blade locks at 180 degrees for spade work. It locks at 90 degrees for pick and hoe use. It folds to 0 degrees for storage in a canvas carrier. The overall dimensions match the German original. The three-position concept is preserved. The compactness is maintained. Production begins in 1943 with manufacturers including Ames Company, American Fork, and Hoe and Wood Company. Various versions would appear throughout production, including later variants with additional features. But there are changes that seem minor in the manufacturing stage. The American engineers replaced the German Bakelite locking collar with a simpler aluminum threaded nut, smaller diameter, thinner walls, softer metal, less grip surface. Manufacturing differences in blade construction and assembly also distinguish it from the German original. The aluminum nut looks similar from the outside. It functions when first tightened, and it streamlines production for an army that needs millions of tools under intense wartime pressure. The aluminum nut would prove to be a significant weakness in too many foxholes from Tunisia to the Rhine. The German Bakelite collar provides massive surface area for hand tightening. Deep-ribbed grooves give fingers exceptional purchase. The hard plastic material resists stripping and deformation under pressure. A soldier can crank down on that collar with confidence, locking the blade solid in most conditions. Once tight, the German shovel typically stays locked, even under considerable leverage, even when used as a pickaxe to break frozen ground or chop through roots. The design isn't indestructible, but it's built with substantial margin for field abuse. The American aluminum nut is smaller, thinner, made of soft aluminum alloy that can grind and deform under stress. The threads are finer. The grip surface is minimal, and when a soldier tightens it in the field, often with cold fingers or in combat conditions, it doesn't always hold reliably. The blade can shift under heavy pressure. The nut loosens with repeated impacts. Corrosion in the desert sand jams the threads, making the nut extremely difficult to remove. Veterans later recall the frustrating process of dealing with seized nuts, various tools and techniques, hours of work on corroded threads. The aluminum construction creates persistent problems. In field use, the consequences are frustrating and potentially dangerous. A soldier locks his M1943 in the 90 degrees position, preparing to hack through rocky soil. He swings down hard. The locking nut gives way. The blade folds. He must stop, retighten, try again. In the precious seconds when incoming artillery demands a deep hole fast, the unreliable lock becomes a serious problem. Many soldiers avoid using the pick mode entirely, defaulting to the less effective straight shovel position because they can't fully trust the lock. Others seek out captured German Klapsen whenever possible. One collector examining original M1943 examples decades later describes the chronic problem. The nut is made of soft aluminum alloy that grinds and chews itself to pieces. When corrosion gets into the threads, they're done. They may as well be welded. The soft metal design adopted under wartime production pressures becomes a permanent weakness embedded in hundreds of thousands of American entrenching tools. The M1943 arrives in American supply chains throughout 1943, 1944, and 1945. Hundreds of thousands are produced. They're issued alongside remaining stocks of M1910 T-handle shovels, creating mixed equipment within the same units. Many soldiers appreciate the M1943 for its compactness and folding convenience, and it functions adequately for basic digging tasks. Others stick with the old M1910 despite its bulk because at least it doesn't suffer from locking failures. Paratroopers use both types interchangeably. Combat engineers carry whichever tool is available, but many soldiers recognize that the captured German folding shovels are superior in reliability. The Klapsbotten holds its lock more consistently. It handles heavy leverage without loosening as frequently. It survives the brutal temperature cycling of desert days and freezing nights with fewer thread problems. When American troops advance through captured German positions, some grab the green-painted German shovels and replace their own M1943S. The German design simply proves more robust in field conditions. The irony is profound. The U.S. military copies a proven German tool, keeps nearly every visible feature, manufactures hundreds of thousands of units, and delivers them to troops, where many discover that the original enemy version performs more reliably. Much of the difference comes down to key components, the locking mechanism being the most significant, the robust Bakelite collar versus the problematic aluminum nut. It's reminiscent of other examples like the jerry can, where American adaptations shaped by different manufacturing priorities didn't quite match the field durability of the original design. Engineering under combat stress operates by different rules than civilian manufacturing. A locking nut that works adequately in a factory test might develop problems in North African heat, European mud, or Pacific humidity. The German Bakelite collar succeeds because it's substantially built, larger, thicker, harder with massive grip surface. It accommodates field conditions where soldiers tighten mechanisms with frozen fingers, dirty hands, or under incoming fire. The American aluminum nut develops reliability issues because it's optimized for efficient wartime production rather than maximum field durability. Softer metal means easier machining, faster production, lower cost per unit under intense manufacturing demands. But softer metal also means the threads can strip under repeated torque. The smaller diameter means less mechanical advantage when hand tightening. The thinner walls mean the nut can flex under stress, allowing the blade to shift. German testing before 1938 proves the Klapspaten design through drops, impacts, temperature extremes, and sustained hard use. The Bakelite collar withstands rigorous field conditions. American engineers in 1942 and 1943, racing to equip a rapidly expanding army under enormous production pressure, adopt a simpler locking nut design. The assumption that it will prove adequate doesn't hold up as well in sustained field use. And the cost is measured in frustrated soldiers, wasted time struggling with unreliable locks, and the uncomfortable reality that captured enemy shovels often outperform American ones in durability. The M1943 remains in U.S. service through World War II, Korea, and into the Vietnam era. The basic folding mechanism proves successful enough that subsequent designs, the M1951 and M1967 entrenching tools, adopt similar folding concepts with improved locking systems, but the chronic locking nut problems with the M1943 persist throughout its service life. Decades later, veterans and collectors restoring original M1943 examples encounter the same seized aluminum nuts, the same stripped threads, the same frustrations that plagued soldiers in 1943. The Klapspaten's legacy endures. Post-war German armies continue using folding shovels with robust locking collars. The basic design influences entrenching tools worldwide. Modern folding shovels, whether military or civilian, universally feature strong locking mechanisms because engineers finally learned what German designers knew in 1938. The lock is everything. A shovel that folds when you don't want it to is worse than useless. It undermines the entire purpose of the tool. The M1943 story reveals a pattern that repeats across military procurement during wartime. Engineers working under intense pressure copy, foreign innovations, analyze the visible features, make changes shaped by production constraints and manufacturing capabilities, and sometimes deliver equipment that looks right but develops reliability issues under sustained field stress. The rolled seams on American jerry cans, the aluminum nut on the M1943 entrenching tool. In both cases, American manufacturers kept the obvious features and changed less visible ones. In both cases, field experience revealed that those details mattered more than initial assessments suggested. A German infantryman in 1943 carries a Klapspaten on his belt. He locks the blade at 90 degrees. He swings it down into frozen Russian earth. The Bakelite collar holds solid. The blade bites deep. He digs a foxhole that might save his life. The tool does what it was designed to do reliably in demanding field conditions. An American infantryman that same year carries an M1943 on his belt. He locks the blade at 90 degrees. He swings it down into North African rock. The aluminum nut gives way. The blade folds. He curses, retightens, tries again. If he's lucky, he'll finish his foxhole before the next artillery barrage. If he's not, he'll wish he'd grabbed one of those more reliable German shovels when he had the chance. The difference between those two soldiers isn't courage, training, or determination. It's a locking mechanism. Key components, details that seemed minor during rapid wartime production, but proved critical in the field. The details that soldiers using the tools in combat conditions understood mattered more than anything else. Because when artillery is incoming and you need a hole deep enough to survive, you don't need a shovel that looks good. You need a shovel that works reliably. You need a lock you can trust. You need the one feature that every soldier needed. A tool that doesn't fold when you don't want it to. If this story of invisible engineering details and the cost of wartime manufacturing pressures grabbed you, hit that like button right now. Every like helps us bring more untold Wabioku stories to viewers who care about getting history right. Subscribe and turn on notifications so you never miss these deep dives into the equipment, engineering, and human stories that shaped the war. Drop a comment and tell us where you're watching from. What other WWII 2 innovations you want us to cover. These details matter. These stories matter. And sometimes the smallest change makes all the difference between a tool that serves soldiers well and one that develops problems when it matters most. Thanks for watching.